Hello. So hopefully you guys had a nice day, had a nice week. Without further ado, let us start with today's lesson. So once again, today, just to be sure, this is the P4 science class, is not the P6 class that's happening at the same time with a different teacher. Last week, we talked about the 3 states of matter, but mainly we talked about solid and liquid. Therefore, today we'll be talking more about gas. Okay, when we talk about solid, okay, the properties of solid, we have to understand that it has a definite volume and a definite shape. Now, whereas for liquid, it also have a definite volume, but it does not have a definite shape. Now, what does it mean by does not have a definite shape? Okay, what does this mean? Like I'm looking at the water in my water bottle, it has a shape. Right? What do you mean by no kind of shape? Ask me. Takes the shape of something. Okay, so it actually takes the shape of the, yes, Ashi, hopefully I'm pronouncing your name correctly. It takes the shape of the container. Okay, so if you look at the water in your cup, in your water bottle, it actually follows the shape of the cup and the container as well. Okay, then what about solid? So some of you guys might be asking, solid, definite shape. Straightforward lah, it has a shape. But things like plasticine, clay, okay, I use enough strength, right? I go and poke it, then it has my finger mark already. So it doesn't have a fixed shape, right? I can just poke a few times with my hand, with my finger, and then the shape changed. So what does it mean by definite shape? Only when you leave it alone, okay, or no push or pull acting on it, or no additional, okay, let me add in the word additional, push or pull acting on it. Okay, so those who are in P6, who have already learned forces, you understand why I use the word additional, because gravity is always acting on them, okay, and it's always pulling them. So when I use the word additional, it's like other than gravity, is there anything else acting on it? Okay, like putting a force on it. So we're going to look at this experiment. I just noticed that my mouse was on the screen. We're going to take a look at this experiment here. We have two 25 ml syringes, colored water, and blue tag. We're going to do we're going to show 2 different videos. One for the blue tag, one for the colored water. So basically put the solid or liquid inside the syringe, and then we're going to press the nozzle. Okay, so we're going to block the nozzle and push the plunger. Then we're going to observe what happens. Okay, let's take a look at the first one. How did we put blue tag into the syringe? We conducted experiment. We conducted a surgery. Okay, I'll explain how we do that later. Okay, so as you can see, we have blue tag, we have syringe, and somehow after we push them away, the blue tag entered the syringe. Okay, so this hand was trying to push the plunger down as much as he can. Okay, so, and we noticed that, or you might have noticed that it did not change despite how much strength he seems to be putting in. Okay, so it has a definite shape and a definite volume. Okay, it has a definite volume because it doesn't compress. Okay, so let's just see from this part again. So with the blue tag in the syringe, you block the nozzle, you push the plunger down as much as you can. Okay, use as much strength as you can without breaking the equipment or the apparatus. And you'll notice that it does not take up less space. So it has a definite volume. Now, so that's for solid. And just now in the recap, we said that liquid has a definite volume as well. So this is a video on showing you how or why do we know that liquid has a definite volume. So now we have blue colored water inside the syringe. This one you don't have to take out the plunger. You can just suck the water in with the syringe. Okay. So after putting a lot of strength to the extent that both person's hands are shaking, okay, the water is still the same amount. It's still taking up the same amount of space. So this means that it has definite volume. So as you can see here, okay, both are pushing so hard until the whole syringe is shaking, and the amount of liquid or the amount of space the liquid is taking up is still the same space. Okay, so this is how we know that liquid also have a definite volume. So based on the experiment, this is what we know. Liquid and solid both cannot be compressed, therefore there is fixed volume. Okay, therefore there is a fixed volume. So before we continue on, there's another term here that wasn't on the earlier slides, compressed. So who can tell me what does compressed mean? Okay, what does compressed mean? Okay, anyone can tell me? Meaning of compress? Press, not just press, push. Okay, nearer towards squeeze. Okay, I will use the word squeezed instead of pushed. Squeezed to occupy less space. Okay, or in the case of the blue tag, is being flattened. It was trying to be flattened. Okay, so squeeze to occupy less space. Okay, so like I mentioned just now, today we'll be focusing more on gas. Okay, today we'll be focusing more on gas. And then we'll also compare the different states of matter. Okay, we'll take a look at the 3 states of matter. So first, when we talk about gas, we need to talk about the properties of gas. Okay, so we'll have a deflated balloon of different sizes. Now, what is the meaning of deflated? Okay, what is deflated? Just in case there are some of you who might have seen the word before and then forgot what it means. What does deflated means? Okay, not inflated or no air. Okay, no air inside. So some of you guys on a more sciencey side might disagree, like, sure, there's air everywhere. I just open the mouth of the balloon a bit, right? The air will go in already. What do you mean by no air inside? Sure, are you high? No. Okay. When I say no air inside, right, we are trying to say that no compressed air. Okay. To be more exact, no compressed air inside. Because when you pump air in, right, air will actually start to be compressed before they make the balloon bigger. Okay, air will actually compress first before they make the balloon bigger, because everything can only be compressed to a certain extent. If you keep squeezing the balloon, it pops, it bursts. Okay, so that means it cannot compress that much. Okay, so let's have a little discussion over here. What would you notice about the shape of the balloon despite the same amount of air being blown into the balloon? So for you guys to have a better idea, we have a normal balloon, we have a normal round balloon, and we have a long balloon. Those are the 2 balloons that we are using. So what will you notice about the shapes? Okay, what will you notice about the shapes when the same amount of air is blown into the balloon, or pumped in this case? So let's take a look at what happened. Okay, when we use an air pump, although it's optional, it is better to use it for reliability to make sure that there is no other change variable. So we have this mad scientist over here, okay, putting 1, 2, 3 pumps of air into the balloon. And then somehow he tied the balloon in a split second. And then he did the same thing with the red balloon. 3 pumps and tied the balloon in a split second. And then he compared the 2 balloons. So let's take a look at the 2 balloons again. Okay, let's take a look at the 2 balloons again. So one is a lot longer while the other one is a lot wider. Okay, so by looking at that, right, by using an air pump, we're trying to make sure, or as close as possible, we are adding the same amount of air into each balloon. Okay, we're adding the same amount, we're trying to add the same amount of air into each balloon. Okay, that's why the intervals between each pump is quite long. Okay, we are trying to make sure that the air pump is filled with air before we pump it back in. Okay, so with this, right, we will notice a few observations. Okay, so like some of you mentioned, the shape of the balloon are different. Okay, so and if you take a look at the steps taken by the mad scientist, he tried his best to make sure that the same amount of air is pumped in. So now, before I ask you, okay, before we continue on, so we can see that the shape of gas, okay, takes up the same shape as the balloon. But what is the original shape of air? Okay, what is the original shape of air? Look all around you. There's air everywhere. Okay, there's air in the cup. There's air between my hands. There's air between me and my shirt. Okay, there's air under my seat. So, is there a shape for air? Okay, there is no shape for air. Okay, there is no shape at all. That's why air can be all around us. Whereas for water, right, although it doesn't really have a fixed shape either, it tends to just flat. Okay, so for water, it tends to be just flat on the surface if there is no container. But for air, it is constantly, I will use the word floating around, okay, occupying as much space as it can. So from here, based on the video, we know that it will take the shape of the container. It has no shape of its own. Therefore, it has no definite shape. Okay, so based on this video, it has no definite shape. Okay, we cannot talk about the volume because it doesn't show anything about volume in this case. Okay, it just shows air occupying space in the balloon. It just shows that it is metal, but it doesn't show it has no definite volume. So we can't say that yet. But of course, we're going to talk about the volume of gas. So when we're testing the volume of gas, it's a lot easier. All you need is a syringe. It can be a syringe of any size. Of course, the smaller it is, the harder to see. Okay, the smaller it is, the harder to see. So we will recommend that you guys use a medium-sized one. Okay, a medium-sized one, something about 25 ml, and then it'll be a lot more obvious. Okay, what about a needle? Please do not put a needle into the syringe. Okay, if you go to those pharmacy shops like Guardian, Watson, you can easily buy a syringe that doesn't come with a needle. Okay, please do not get one with a needle. Because if that's the case, I'm pretty sure we will not be able to conduct this experiment. Okay, it will be very, very painful for one of the person here. Okay, so as you take a look, since we're just testing for air, we just, well, pull the plunger, let air enter the syringe. If there's a needle there, this hand will not be able to be placed there. Okay, So it's a bit fast. So let me rewind that part a bit. Okay, so as you see, when the nozzle is being blocked, the plunger is still able to go down. Okay, let me pause around here. So as you can see, the plunger can still go down. Okay, the plunger can still go down, although the nozzle is blocked. Air shouldn't be able to escape at all. So this means that air can be compressed. But the interesting thing is, when the hand on the left, okay, when the hand on the left let go, okay, you notice that the plunger follow him. He's not pulling it. He's only using his thumb. So this means that the compressed air, right, actually pushed the plunger back. Okay, or some of you guys might know air pressure. Okay, so no matter how much you are trying to compress air, no matter how much you are trying to compress air, air cannot be fully compressed. So as we mentioned, compression means that it takes up less space, so the volume of air becomes smaller. Okay, the volume of air becomes smaller. So air fills out the space of its container, also takes the volume of its container. Okay, now, if that's the case, right, let me ask you guys one thing. If there is a 500 ml container, okay, and there is 200 ml of water, what will be the volume of air? Okay, it will be 300. So it will take up all the remaining space. Okay, it will take up all the remaining space. So although the volume will follow its container, but if there's other matter inside, be it liquid or solid, it will only take up the remaining space. Okay, because it's very shy, it doesn't like to mix together. Since air can be compressed, it shows that it does not have a definite volume, and it can take up less space by being compressed. Okay, so air does not compress, right? Air does compress. Okay, air does get compressed. As you can see on the last sentence here, this shows that a gas can be compressed. Okay, based on that, right, we can now add gas into our table that we've seen just now. So air can be compressed and it does not have a fixed volume. So, but if I want to make this table even more complete, okay, is there any other properties I should put it in so that I can easily compare all three states? Okay, does it have a fixed shape? So for gas, does it have a fixed shape? It does not have a fixed shape. What about liquid? Does it have a fixed shape? Okay, then a lot of people say no again. Then what about solid now? Does solid have a fixed shape? For solid, yes. So this will be a more complete table when you want to differentiate between solid, liquid, and gas. Okay, so this will be a much more complete table when we want to compare solid, liquid, and gas. Okay, so if in an exam or in a test, they ask you more about solid, liquid, and gas, how do you differentiate it? Just look for the difference, like between solid and liquid, and even gas, the shape is definitely different. Gas is the only one that doesn't have a fixed volume, and it is the only one that can be compressed. Okay, so hopefully it's clearer for everyone else here. So with that, let us proceed on to the questions. Let us take a look at the first question. So you're supposed to take a look at the classification chart. and then correctly classify additional objects, into the chart, okay, to answer this question. So the correct answer is 3. So before I explain why the answer is 3, we need to take a look at the classification chart first. Okay, we need to take a look at the classification chart first. What do we know about group A? Okay, or maybe the easiest one is actually group C. The easiest one is actually group C. What do we know about stone and marbles? How are they similar to each other? Okay, as a form of metal. How are they similar? They are solids. So these are the 2 possible ones. It could be because they are solids, or it could be that they have a fixed shape, one or the 2. Okay, so we are not sure yet. So now we have to take a look at the next one. So the next one that most of us should be familiar with will be like milk. Okay, will be like milk. So if you take a look at milk, right? Milk is something that we drink. Therefore, group A should be liquid. Okay, group A will be liquid. And we will not talk about the shape. Okay, we will not talk about the shape. Now, can anyone tell me why we will not talk about the shape? Why do I say that? Oh, it could be shaped. But after looking at group A, it is not possible to talk about shape after that. Why can't I still continue to say that, oh, group A has no fixed shape or no definite shape? How come I say that, oh, if that's the case, shape is not part of the header, or not how they are grouped? Okay, so the main reason is, right, group B also has no fixed shape because it's gas. Or another way to look at it is, if you are talking about shape, there's only 2 possible groups. Okay, if you are talking about shapes, there can only be 2 possible groups. So it's either has a fixed shape or don't have a fixed shape. Then if that's the case, I shouldn't be splitting into 3 groups at all. Okay, so that's why after looking at group A, then you might notice, hey, wait, there's one more group. What am I going to put there? What? Have a bit of shape? That doesn't make sense. Okay? So that's why when we talk about shape, we cannot use it here. Although it is a possibility at the start. Okay? So snow, right, is actually solid. So some of you guys might have seen snow before and like, but sure, I can easily move the snow around. Okay, that's how is snow a solid. I can make it into a snowball, I can make it into a snowman, I can make snow angels. So how is snow a solid? Snow is very similar to sand. Okay, snow is very similar to sand, whereby they are very, very small. They are very, very, very tiny solids. Okay, they are very, very, very tiny solids. Therefore, they are considered as solids. Okay, some of you guys have seen snow once. They are very, very tiny solids. Okay, similar, even smaller than sand. Okay, oxygen is a gas that we all breathed in, and water bubble is actually a layer of water. Okay, a layer of water that is trapping gas inside. So when we talk about the bubble itself, it's liquid. Okay, so some of you guys like, huh? Snow is actually solid. I have no idea, mind blown. It's perfectly fine because you don't see snow in Singapore. Okay, but you have to be aware that snow is solid. Okay, you don't suddenly go to other places and say, oh no, it's raining, it's snowing, we're going to get wet. Well, you're not wrong. That's not because of the snow itself. It's because the snow melted or the snow changed to water. Okay, let's go to the next one. So now we have Susan. Okay, we have Susan, and she made some observations on the states of water and recorded them in a table below. So which of the following correctly identify the different states of water in A, B, and C? So in case you guys haven't noticed, water is the only object in the world. Okay, I'll not say the only object in the world, but it's one of the most common objects that can be in all three states. Okay, easily. It can be in all three states easily. Okay, water, we can have it in the form of gas, in the form of liquid, in the form of solid, like ice cubes and snow. So with that, what will be the correct answer for question 2? Before we go to the options, we have to first identify the different states for A, B, and C. So A has no definite shape, no definite volume, and can be compressed. So if that's the case, right, what state is A? Okay, what state can A be? Okay, will it be solid, liquid, or gas? Okay, it will be gas. So how do we know the obvious one is this one? Okay, so A is gas. Then which one will be solid, B or C? Okay, so solid will be B, yes. Because when I talk about solid, we'll be talking about definite shape. Okay, when we talk about solid, we'll be looking at definite shape. Therefore, B is solid, and the last one will be liquid. So let us identify which ones are correct then. So for A, it must be gas. So it can be 1, 3, or 4. For B, it must be solid. So solid can be 2, 3, or 4. And the last one has to be liquid, which is only one option, 3. Okay, which is only one option, and that's 3. So a water droplet, it just means a drop of water. That's why the answer is 3. Okay, so hopefully those who misunderstood the question have a better understanding of it now. Okay, so when I talk about when something has no definite volume, it has to be gas. When something has a definite shape, it has to be solid. And then the last one will just be liquid. Okay, the last one will just be liquid. Okay, so now we have another person making more observations. Okay, now we have another person making even more observations. Okay, now, so take a look at the question. So Shu Hui made some observations of substance P, Q, R, and S in the table below. So we'll be looking at the definite shape and whether can it be compressed. Then we need to identify which of the statements can we conclude from her findings. Okay, can we conclude from her findings? Okay, so that means which of the following statements is true based on the table. Okay, so when we say conclude, basically what can we know for sure, okay, from the table. So let's take a look back at the question, okay, because the time is up. So easily, once again, if we take a look at definite shape, we will know that they are solids. Okay, and if we see that it can be compressed, this has to be gas, and the last one will be liquid. Okay, once again, there is no plasma in our syllabus, so we do not need to take into consideration. Okay, so it does not need to be taken into consideration. Okay, so R is gas, Q is liquid, P and S are solids. P, Q, R, S have mass. Okay, how do we know they have mass? Okay, how do we know they have mass? Okay, so we only know their state, but how do we know they have mass? Like, it's not shown in the question. Yes, all matter has mass. All matter have mass. So if they are solid, liquid, or gas, they will definitely have mass. And someone just now is asking, Joe, what is mass? Is it making a big mess? No. Okay, mass refers to amount of substance or amount of matter an object has. Whereas volume is the amount of space. Okay, while volume is space, how much space the object takes up. Okay, then weight is slightly different. You'll actually learn more about weight in P6. Okay, weight is actually due to gravity. But once again, there is something that is not exactly needed for, like, you don't need to know more about gravity now. And Q has no definite volume. This is not correct because Q is liquid. So answer is 4. Okay, so now let's take a look at question 4. So question 4 is a flowchart question. So you're supposed to start at the top. So you're supposed to start there. And then we have to identify which of the following statements are true. Okay, so let's take a look at the flowchart. So does it have mass? If it's a yes, or this must be, oh, I'm still at the highlighter. So everything below here must be metal. Here will be non-metal. So if that's the case, right, anything that is non-metal will be X. So X is correct. Okay, does it have a fixed volume? No. Okay, yes. So this has to be gas. Okay, gas is the only one that doesn't have a fixed volume. Does it take the shape of the container? Yes. So this has to be liquid. So nothing is solid in this case. Okay, Z cannot be water since Z has to be liquid. And then Z is a gas. Remember, matter is everything that have mass and occupy space. Okay, mass and occupy space. So things like light, shadow, heat, sound, okay, they do not take up space at all. Okay, it doesn't take up space, you cannot weigh them, so they are considered non-matter. Okay, so with that, the answer is what? Okay, so let's take a look at the next one. So now we have Mabel. Okay, Mabel is conducting an experiment as shown below. So what will she observe? Okay, what will she observe? If she blew air into the rubber tube. So when you blow air into a tube, where will it come out? As you can see, the answer is 3. Okay, so when she blows air, right? When she blows air into the container, okay, it will enter the container. So there'll be more air, okay, or more gas. So what happens if there's more gas in the bell jar? Okay, what will happen if there's more gas in the bell jar? If there's more air or more gas, it will take up more space. Okay, it will take up more space. So firstly, it will try to compress itself, but if it cannot be compressed anymore, it will try to take up more space. So what else is taking up that space? it will be the water. It will be the water. So it will push the water down, causing the water level outside to go up. Okay, causing the water level outside to go up. So there's not much time left, and we still have a few more questions. Let's go continue on to the next one. Okay, question 6. So what will happen if Hashim, okay, poke a hole in the cup? What will happen? Okay, how will which diagram looks correct? Okay, so for those Apple fans out there, whenever a new product is out, you'll definitely queue very long and you want to rush into the shop. You want to rush into the shop. So if you want to rush into the shop and there's only one door, are you able to rush in easily? Cannot, right? Because if the door is blocked by other people, or in this case by other water, no one else can go in or go out. Same thing here. Okay, once the hole is covered with water, the rest of the air cannot escape. They are stuck inside because the only way of escaping is blocked by water. Okay, the hole is already filled up by water. So if that's the case, air cannot go out anymore unless somehow it can push the water away to make its way out. Okay, so eventually air will actually get more compressed and they will still stay stuck in the cup. So not all the air will be able to escape successfully. Why? Because once again, if the hole is already blocked off, by water, air got nowhere to run to. Okay, air got no way to run to. Okay, so basically, if like there is fire here, fire is blocking your door, you cannot run through the door, right? If there's a fire, will you want to run through the fire to the door? No, right? Because it'll probably be very hot. So you are trapped inside. You cannot run away. Okay, you are trapped. Okay, break the glass. Okay, if you are staying in a glass place, then yes, please break the glass to run away. Okay, so now we have a different question. So for this one, now we have John pushing an inverted cup. Inverted cup means the cup is upside down. Okay, the cup is upside down into the basin. So he wants the cup to be completely filled with water. So what should he do? The reason why it is not completely filled, right? Okay, reason why it is not completely filled with water, it is because of trapped air. Okay, it is because of trapped air. So we will need to look for ways to let the air escape. Okay, you need to look for ways to let air escape. Adding more water does not help. If you put a hole at the base of the cup, air can escape, so correct. So pushing it further down does not help. The air is still trapped. So the answer is 2. Okay? So this question is pretty easy. So I'll just launch the question now. So in case you guys can't see, this is 200 cm³ of air. This is 50 cm³ of air, although it is also stated in the question. Centipedes eat millipedes? Oh, okay. I know millipedes are smaller than centipedes as well. It's pretty easy because we're talking about air. Okay, we're talking about air, and air can be compressed. air can be compressed and it will take up all the space in the jar no matter how much you put in. Okay, so that's why the answer is 2. Okay, so that's why the answer is 2. Of course, you can only push in to a certain limit. Okay, you cannot push in all the way. So this is what we have covered for today. Okay, so this is what we have covered for today. So you can take a look at this. So with that, we have reached the end of the lesson. Okay, with that, we have reached the end of the lesson. So if you have any other questions that you want to stay back and ask, you can do so. If not, then I will see you guys